Thank you, Sebastian. Good afternoon. I'm going to present a case study of a sustained multi-stage effort to change and simplify the core data relationship in a production system. Changing code has its challenges, but changing the data model of production data is even more difficult. Protecting the existing data requires caution. Exploring and testing possible solutions can be slow. Your new data model may require data completeness or correctness that hasn't been enforced for your existing data. But living with a data model that is a mismatch for your business is also painful. It introduces extra complexity, pitfalls where bugs can lurk, poor performance, all those kinds of things. And we rarely hear about the details of this kind of change. So hopefully this talk will be helpful for those of you who have to tackle something like this. We did this work in 4 stages over 2.5 years. At each stage, we tackled the biggest problem we were facing, driven by business considerations, and then returned to feature development for a while until the next big problem started to become costlier to live with than to fix. You can see that stage 2 began with a short spike and then a 5-month gap before the real push began. It was 30 months. At the beginning, we had no idea what was ahead of us. And we might not have started if we had known what it would involve. But on the other hand, looking back, it feels amazing, and it feels like it's gone quickly. We made a lot of progress, and we're glad we are where we are now. There are quite a few technical details in this talk, but it's not about the technical details, because I can pretty much guarantee that yours will be different. All 4 of these stages, the technical details were very different. This talk is about the overall strategy and how to do this responsibly. We tried to apply these principles at every stage, and you can pay attention through the talk to how we did that. This whole thing started with a couple of big mistakes. So I'll start with those to set the rationale for all this work. We at first help real estate agents win more business by focusing their effort on the right people at the right time. The average realtor has a database of a few thousand contacts, and we use predictive analytics and other techniques to help agents focus their marketing efforts wisely. This seems like a good time to mention that we are currently hiring Rails developers. A startup's job is to try a bunch of things and figure out what doesn't work on the way to finding out what does work, and we certainly did a lot of that. When we first started looking at this problem, our basic data model looked like this. We had realtors as customers, and each of them had a bunch of contacts. And we started thinking about all the things we could do with this data. So we thought it might be cool to know that Pat is married to Lee, or that Jane knows Robert. And then it could be great to know that our customer Abby also knows Quentin and Sally, and that our customer Bill also knows Kathy and Nancy. And that led us to our first big mistake. We're building a social graph. And that in turn led to our second big mistake, which was to put all that data in a graph database. Now, I don't believe that's necessarily a mistake for everybody, but it certainly is when you eventually figure out, as we did, that we weren't actually building a social graph. So now I'm not going to talk much about relationships between contacts today. Our focus will be on relationships between realtors and their contacts. But remember that the other relationships are there. And the notion of this as a social graph led us to thinking of these contact records as representing the actual people, the actual Nancy, for example, as opposed to just Abby's contact info for Abby, or for Nancy, or Bill's contact info for Nancy. And we made a lot of other mistakes too, and I don't want us to get bogged down in wondering exactly how all those things happened. Just remember what Jerry Weinberg said, and bear that in mind when I show you where we were 2.5 years ago. 2.5 years ago, we had what we thought of as business data about users and some of their activity data and stored data in Postgres, and all the contacts and social graph stuff in Neo4j. And to link the users to the data in Neo4j, we had these what I'll call realtor prime proxy objects in Neo4j. All those CR nodes are contact relationships. Neo4j reifies all relationships as nodes, and its query language Cypher encourages you to think of them that way. But my guess is that you, like me, think more in terms of tables. So for convenience, let's draw it that way. And you can see that contact relationships is a big join table. Contacts were shared between realtors. And so we had to use the source information for every attribute, names, phone numbers, emails, so on, to determine which information each customer was allowed to see. We would have tracked that source info anyway, but for other purposes, and we wouldn't ordinarily have used it to handle the data privacy concerns for our customers. But it had to be included in every query because the contacts were shared between realtors. Here's the structure we actually need and that we have finally achieved today. Note that shared contacts have now been duplicated and the join table is gone. We didn't know for sure at the beginning that this is where we needed to end up. The big problem, so big it obscured everything else, was having our data spread between two databases. So we started there. And that's where this talk starts, getting the data out of Neo4j. What drove the change? Well, Neo4j and Cypher, the query language, were not as familiar to the developers as Postgres and SQL. The active model gem for Neo4j, at least at that time, was less mature and feature-rich than active record. Neo4j's drivers were less mature and less well-optimized, and the entire database, for that matter. It's just a newer product. And some features, we eventually developed some features that required cross-database joins, and you can imagine how slow and memory-intensive those were. So Rob Sandheim and I sat down to start making a plan, and we decided to migrate people across realtor by realtor. We started building an importer job that would import a realtor's Neo4j data into Postgres, and that importer needed to avoid duplicating the shared data that had already been imported for another user, and we would use a feature flag to indicate whether a user had already had their data migrated over or not. We started with schema definition. We knew our data in Neo4j was messy. Neo4j's referential integrity features are weaker than Postgres's to begin with, and our knowledge of those was weaker than our knowledge of Postgres's features. So we weren't using them very well, and so we got very serious about data integrity in the schema. We used foreign keys, on cascade, delete, and restrict declarations, check constraints, exclusion constraints, anything we could think of to encode the constraints on our schema, on our data into the database schema. This was enormously helpful. The constraints caught most of our messy data during importer testing and forced us to figure out how to deal with it and clean it up right up front. The feature flag needed to be readily available throughout our entire code base, and so we used middleware to set a thread local variable early in the request cycle. And then we had a problem. A lot of queries start off by calling class methods on a model class, like those there. We needed that model class to be a Neo4j model if an active record model if the current realtor's feature flag was set, their data had already been migrated over. We needed it to be a Neo4j model if not. How do you do that? Well, Ruby's dynamism to the rescue. We were able to build models that could switch back and forth based on the feature flag. To use contacts, for example, contact was this very small class that extended a switching model module, which we'll get to in a minute. And then it declared, I'm going to switch between contact v1 and contact v2. Contact v1 was the Neo4j model. Contact v2 was the active record model. You can see contact v1 includes Neo4j active node, declares that its actual node label name is contact, and then has a bunch of code specific to that. And contact v2 extends application record, declares that its table name is actually contacts, not contact v2s, and does a bunch of active record stuff. Switching model is a little module with all class methods. Switch between just stores those two models in class instance variables for later use. There's a v2 mode query method that checks the thread local variable to see which mode we should be in. V2 is Postgres, V1 is Neo4j. You can see that there's an environment variable-based override of that feature flag there. We use that in testing. And a switch method that simply returned either the V2 method or the V1 method, depending on what the mode of the current user was. And then everything else is delegation. With method missing, const missing, and new, we just delegate those to the object returned from switch, and away we go. So most of the code did not need to know that there were these two different kinds of models. The controllers could just use the models and get the data that they needed for that user. When we started this work, a lot of the queries included cipher fragments, and we found that it helped a lot to convert those into scopes so that we could mirror those with active record scopes. And again, the idea was that controllers wouldn't have to do things differently depending on where the data was coming from. They would just call, contacts.follow. Non-realtors and so forth, and the scopes would hide all of the database dependencies. We ended up building a rich vocabulary of scopes that has served us well ever since. And queries in our system are generally very pretty and easy to understand. For testing this, like I said, we had an environment variable override of the feature flag. We used that to build two different rake tasks for running the two sets of specs. We had separate sets of factories. We set up CI running both sets of specs. And for actual testing, QA work, we did a lot of manual testing by developers, comparing old version of users' data and new versions. And toward the end, we had a whole company QA swarm on our staging server. Our CTO and at the time my boss, Jess Martin, gave me some excellent advice. He said, since feature development is going to be so slow for a couple of months doing this, it would be great if you could find a way to radiate to the rest of the company that you're actually making progress, that all this back-end work that they can't see is actually getting closer to being done so we can get back to feature development again. So I wrote a custom RSpec formatter that counted up how many total V2 specs there were and how many passed, spit that out as a CSV record, and that got dropped into a spreadsheet with a chart that was published into our project management system and showed that we were gradually converging with being complete with all of this work. When it came time to execute, we did select employees first, those not participating in sales and demos, then the rest of the employees, then some friendly customers who wouldn't get mad at us if they saw any problems, then the rest of the active customers, and the whole process of actually running all this stuff took about 3 weeks. After the initial round of employee and select customer migrations were done, we started the first full batch of customers. All of a sudden, for the first time in about 2 months, I had nothing to do. So I thought, well, I may as well start on the PR to rip out all the V1 and transitional code. And 10 hours later, I submitted one of my favorite PRs of my entire career. And that was a very satisfying moment. After that, here was our data model, the part we're talking about today. Contacts were still shared, and the join table was there, but at least it was all in Postgres. So, time for stage 2. I mentioned that the importer had to make sure not to duplicate shared data that had already been imported from other contacts when it was pulling it into Postgres. Neo4j attaches UUIDs to all of its nodes. And I thought it would be a good idea, for some reason, to solve that duplication problem by carrying that across and making the UUID the primary key of those tables in Postgres. That turned out to be a big mistake, and I soon had to fix it, and that's stage 2. Don't get me wrong, Postgres UUID primary keys work just fine. They're a little harder to remember, harder to compare when you see them in output, harder to type, of course. But it didn't really become an issue until we needed to start tracking source info for a different table that had an integer primary key. We tracked sources using a polymorphic table called sourcings, polymorphic join table. All the sourceable tables that it pointed to had UUID primary keys, and we realized we needed to start tracking source info for this other one. We could have hacked around this a number of ways, but we decided to fix it. So when I first realized we would need to do this, I set aside a couple of evenings and did a spike. And I came up with a strategy, and it works like this. So first, we start off by adding an integer ID column, using contact names as an example, and giving it the serial option in the migration so that it auto-populates based on a sequence. And then we pre-populated it. Then we dropped the primary key constraint on ID, renamed that to UUID, and then finally, we renamed integer ID to just ID and reestablished the primary key constraint there. Simple, we're done. That's the simple case. If you have foreign key references to that table, it gets harder. So here's properties and property notes. First, we add an integer ID column to properties, and we populate it. And next, we add an int property ID column to property notes, and we populate that by joining across to properties. Now it's time to drop both the primary key constraint and the foreign key constraint, and then rename ID to UUID. We're about halfway there. Now drop the old property key column, rename properties.integerID to ID, rename int property ID to property ID, and finally, reestablish the primary key and foreign key constraints. And the more tables you have that have foreign key references to your table, the more complicated this gets. And this led me to developing some primary key helpers, so some migration helpers to do the various bits of this work. Another problem is polymorphic tables. It's a theme in this talk that polymorphic tables complicate everything. And they did here, and this all started because of one of those. When you have a polymorphic table that points to some of these things, that meant you had to convert all of them as a group in one batch. We ended up with 5 separate clusters of tables that had to be converted as one, and wrote those migration helpers to manage all those details, and actually I went to the trouble to make the migration helpers reversible. And tested those round trip with both the schema and the data to make sure you could go round trip and end up with what you put in. Just as a side note, I'm sure many of you know this, but in a relational database you can discover anything about the schema from a set of internal tables and views. So here's an example of finding out all the foreign keys that point to the context table. You can do similar things for indexes and other kinds of constraints. So the output of the spike was these 3 complex migration helpers for primary key, foreign key, and polymorphic references. 5 migrations, and we ended up waiting 5 months before the pain of living with this outweighed the risk of going ahead with the change. The first migration was very simple, it was very easy. Harder cases are a little more complicated, and the worst case was truly horrifying. Changing all those tables in production at once overnight. But when it came time to actually execute this, we did a careful review of all those migrations and helpers, got somebody else to look at it. We ran the migrations many, many times on clones of the production database. Run it, fix an error, and repeat. I learned to be very, very thankful for Postgres' transactional DDL. Every time one of these migrations failed in the middle, if I had not known that the schema was still unchanged and not half finished or corrupted in some way, it would have been a disaster. That safety net was fantastic. Fixing the error usually meant figuring out how to reflect on some new kind of dependency or constraint in Postgres that I hadn't seen before, and updating the helper to deal with that, sometimes just coding a workaround. We tried to be very careful with this. We ran the migrations in staging to get the timings. At our company, we have the luxury of being able to schedule downtime on the weekends, but we still wanted to know how long the maintenance windows would be. Like I said, we made them reversible. We planned to never have to, but We tried to make everything reversible when we're dealing with production data. We built random spot checks into the migration helpers. Remember I said we kept the UUID column for later record keeping. At the start of the migration helper, we would grab a random sample of the records from the table we were about to change and store those, and then after doing the migration, before committing the transaction, we would verify that those all pointed to the same things they pointed to before. And we wanted to make sure that even as we were running it in production, we had some spot checks that would bail out if something went wrong. So after stage 2, nothing dramatic changed about the layout of the data model, but everything was uniformly using integer primary keys, and we were able to start tracking source info for more things. Stage 3. It was finally time to separate the contacts so that there was no data shared between realtors. Swanand Pagnus, who has been my partner in crime for all of this work, ran point on stage 3. He had a really good grasp on the problem and what was required, a much better grasp of it than I did. So he took charge, and I was playing the support and validation role. What drove this change? Well, I've already mentioned that nearly every query had to be filtered based on where the individual pieces of data came from, so we wouldn't show like Joe's unlisted phone number that he only shared with realtor Abby to another realtor that wasn't supposed to know that. That was extra complexity. Joining through that polymorphic table was slow. And finally, there was a business risk there. We knew that sooner or later we'd miss something and violate customers' data privacy, and that was not something we wanted to live with. So, Swanand did a spike on this to evaluate different ways of accomplishing it. Doing it with Ruby was very straightforward, but it would have taken about a day per contact, or per realtor. And at that rate, we would still be doing it. Doing it in SQL required fairly advanced skills and techniques, but it took about 10 minutes per realtor. So we went that way. And as with stage 1, we decided on a realtor by realtor approach, migrating realtors' data one at a time. Swanand worked this out pretty carefully. This is a page from his notebook where he mapped out a fairly complex scenario and looked at all the implications and proved to himself that he understood what needed to be done and how to do it. And he posted this as an attachment on one of the PRs to document that to the rest of the team and let them see what he was up to. The strategy works like this, and I'm going to show a very simple example showing one contact that's shared between 3 realtors. First, for some initial preparatory work, we added an old contact ID column to contact relationships and pre-populated it with the current value of contact ID, so that we could, after we changed the contact ID, we could know what the original one was. And then we added a contact relationship ID column to contacts and populated it with null, which I'm representing with an emoji. And then we added a uniqueness constraint for that column so that no 2 contacts could have the same contact relationship ID. So let's start with Alice. First, we update the contact relationship ID for every contact owned by Alice if it's null. You can think of this as claiming that record, that contact record. This one now belongs to Alice. And then, for each of Alice's contact relationships, we insert a new record into contacts. But if there's a conflict, if it would have the same contact relationship ID as an existing record, we don't do that and instead just set updated at. But once that insert is done, then we update the contact relationships to point to the new contacts we've created where they exist. This is all done in one big fancy query, and this is simplified from what it really looked like, but it's still pretty complicated. We can zero in on parts of it and see what it does. First, we select all of Alice's contact relationships and the contacts associated with them. And then we use that to insert new contact records based on all of those contacts. Some of them will work, but some of them will run afoul of that uniqueness constraint. And in the case where there is a conflict and you can't insert a new record because it would be a duplicate, we just update, set updated at to reflect that something was changed, but not really do anything else there. In other words, that record was already claimed. And finally, this is all wrapped up in a common table expression called new contacts that returns all of the newly inserted contacts records, not the ones that got canceled because of the uniqueness constraint, just the newly inserted ones. And that common table expression is used to update the contact ID field in contact relationships to point to all those new records. So back to Alice, we try to insert there, but there's a conflict on that uniqueness constraint, and so that insert does not happen. So nothing really happened there because Alice had already claimed contact 1. But let's look at Bill. We try to claim the contact for Bill by updating contact relationship ID, but it is not null, so that fails. So we don't update it and we don't claim that contact for Bill. Now we insert, and the insert works because it doesn't create a uniqueness violation. And then the update fixes the contact relationships record to point to that new contact. But what about the attached attributes? Well, this is simpler than it looks. For each of Bill's contacts where contact relationships .old contact ID is not equal to the contact it points to, we just go find that old contact and copy all of the attributes over down to the new contact. It's a lot of queries, but it's basically straightforward. And then we move on to Carl, but I'm not going to show you that part. So once again, we ran all this stuff many, many times against a clone of production. We would run it for a realtor and compare that realtor's data against their production data. We did a complete run-through of converting all the realtors in staging before running on to production. And during that run-through, I plotted the changes to table counts as a sanity check, and I saw something disturbing. One of those tables is growing much, much faster than the others and than you'd expect. It turns out to be our old friend sourcing. So remember, polymorphic tables complicate everything. And Swanand went and looked at this, and you can probably guess what happened. There was an outer join that should have been an inner join. And so he fixed that and reran that full run through, and I was able to watch that graph level out into a much more sane output, and we went ahead and ran everything. At this point, this was what our data model looked like. No more shared contacts, but the join table is still there even though it's not really necessary. And that leads to the final stage, getting rid of that join table. What drove this change? Well, I've already mentioned that everything's just a little more complicated with that join table there. The database is representing it as a many-to-many association when we have rules now that it has to be a one-to-many association. So that required constraints and integrity checks that if the join table weren't there wouldn't have been necessary. It probably wasn't a big enough problem for us to proceed with it on the schedule we did, except that one of my team members, Monty Johnston, challenged me. Say, what can you figure out to get rid of contact relationships? And I thought about it for a while, and then I realized that there was a way to set this up so we could pursue the rest of this work opportunistically instead of having to stop everything and focus on it. The idea was we would go ahead and add the direct foreign key relationship from contacts to realtor and populate it to match the existing contact relationships. And then it's a simple matter of making sure that the two ways of representing the association stay consistent using triggers. Rails developers are wary of stored procedures and triggers for good reason, but sometimes they're exactly what you need. And this is one of those times. So I had a lot of ignorance to overcome. I had never written a trigger before. I knew what they were and how they worked and the circumstances when you'd use them, but I'd never written one. So I curled up with the Postgres manual and tried to figure it out. And there's some complications here. So at the start of this work, all of our code was working directly with the contact relationships table. And so when you did an insert into contact relationships to set a new association between a realtor and a contact, we then wanted a trigger to be invoked to go and set the realtor ID on the contact to keep the two consistent. Well, then at some point our code would switch over to working directly with that direct association. And in that case, we would want, when we set realtor ID directly on a contact or created a contact with a realtor ID set, we would want a trigger to be invoked to go and insert into the contact relationships table to keep the two consistent. Now, if we could have guaranteed that there would be an instant where on one side of that instant, everything's working the old way, and on the other side of the instant, everything's working the new way, that would have been fine. But I didn't have confidence that we could guarantee that, and we didn't want to test it. And that leads to the possibility of an infinite regress. You do this insert here, that invokes a trigger that sets contact ID over on, or realtor ID over on the contacts, and then that in turn invokes the other trigger. And it needs to know to stop because it's already consistent. And likewise, going the other direction, you set the realtor ID, that causes a trigger to insert a contact relationship, which causes a trigger to go try to set realtor ID, and we need that one to stop because it's already consistent. Triggers are hard for me, at least. It was hard to think about. I'm just not used to thinking that way. I had to learn a lot of arcane Postgres SQL syntax that I wasn't familiar with. For efficiency, I had to control the conditions under which they were invoked. You don't want to even invoke the trigger if none of the data they care about is changing. For correctness, in some cases, the trigger needed to happen before the update happened, the initial update, and in some cases after. And then I had to carefully write those updates and inserts so that they would only make a change if something was out of sync, so that they wouldn't trigger an infinite regress of these things. And let me tell you, if you've never gotten a Stack Overflow exception from within the bowels of your database, you haven't lived. So we came up with a plan. First, this was part of the transparency again, build a way to track our progress toward this, to keep us motivated, to show the rest of the company we were making progress. Step 2, build a way to audit the activity of the triggers. This is related to validation. We wanted to make sure once they were in production that they were doing what we expected them to. Step 3, add the primary key, foreign key reference and the triggers. There were 3 steps where I moved individual fields that were stored in contact relationships over to contacts directly. 2 steps where I retargeted polymorphic associations, sourcings, and taggings that initially pointed to contact relationships and now needed to point to contacts. 3 more where I just cleaned up all the rest of the stuff, retargeting associations and scopes and query fragments. And finally, step 12 was dropping the table. For tracking progress, I just set up a little script to count the references to contact relationship in our code base and plotted it the same way. You can see we went from a little over 200 down to nothing in a couple of months, 3 months, I guess. For auditing the activity of the triggers, I updated the triggers to log each invocation into this contact relationship trigger actions table. It would include which trigger it was, the IDs of the relevant entities if it had them available, and a timestamp, and then whether it actually performed an update as a part of being invoked or not. And I wrote a little utility script to audit this for consistency. And we ran it periodically, and if we had ever encountered an inconsistency where the counts weren't pairing up like I expected, we would have stopped everything until we figured out what was going on. I did most of this work, and I would imagine I spent 8 to 10 hours a week, doing one of those steps, gradually taking it through. We did most of the deployments on weekends just to minimize risk, even when there was no downtime required. And finally, this is what the data model looks like. And it feels good. It's a structure that really suits our business, and we're poised for the next stage of our development. So, what can we learn from all of this? I recommend this incremental, slow and steady, worst pain first strategy. It helped us contain risk. It allowed feature development to continue for most of the time we were doing this. And in spite of the fact that at times it seemed slow, it produced enormous improvement over time. We always keep looking ahead to things, how we can improve our system architecturally. We have an informal kind of pain inventory of what's causing us grief or what's too complicated that we'd like to change in the future, and it allowed us to easily pick the worst one and get working on it when we had some free time. You'll notice each of these stages is different. Entirely different solutions required at each step. Stage 1 was Ruby magic. Stage 2 was migrations and database reflections. Stage 3 was fancy Postgres insert on, upserts and common table expressions and things. And step 4 was triggers. And entirely different testing strategies to go with those. There's no recipe. You have to figure out what works and figure out ways to make yourself confident that everything's right before you pull the trigger on it. One thing that they all do have in common, though, is leveraging the database. We Rails developers love Active Record and Arrow for queries, and that's fine, but for all its flaws, SQL is enormously powerful, and the referential integrity protections that good databases offer can save you, and learn to rely on them and get disciplined about that. As I mentioned, without Postgres' transactional DDL, the risk and effort would have been an order of magnitude larger. And finally, even stored procedures and triggers have their place. Although I was particularly glad that in this case, we had a clear time frame where we put it in, and then at some point we could take it out. As I mentioned, we have the luxury of being able to schedule maintenance windows on the weekend. If you can do that, if you don't have that luxury because of your business model, you have to explore other techniques, and I would recommend pulling in an experienced database consultant to figure out how to do some of these things in that kind of an environment. These kinds of tasks really benefit from having a lot of focus. And frankly, it helps if you have somebody on your team who's maybe a little neuroatypical and able to get super obsessed with these things and not let them go. But at the same time, that can blind you to, oh, I'm getting too clever here, or this is too complicated, maybe it was a bad idea and we should rethink it. Make sure you come up for air and have somebody looking over your shoulder, second guessing some of this stuff to keep you on the right track. Would we do anything differently if we had it all to do over again? If we had clearly understood our end goal, it's probably pretty obvious that we could have done all 4 of those stages as a part of stage 1. Just never copied the contacts over from Neo4j, never shared them, never put the join table there. We would have gotten all this way in the first go. And I really wish we'd done that, except we didn't know that this was our goal. We knew that the benefit we were getting from having Neo4j was not worth the cost of having our data spread across 2 databases. But we still kind of thought we were building a social graph. And so we probably would do the same thing again, given what we knew then. It's dangerous to try to guess too much about the future of your business and how it's going to change. On the other hand, there's one thing we did that I think clearly we would do differently in retrospect, simply because we didn't need to know the future of our business. We just needed to know some technical principles. And that is, we should never have used UUID primary keys for those tables. I didn't need to make it the primary key to keep it around and use it to avoid duplication. I could just stick it in another column where it ended up anyway, eventually. UUID primary keys are only useful if you really need to distribute the work of generating new keys outside the database. And I can think of 2 cases where you'd need to do that. One is if contention on the sequence in the database is becoming a bottleneck, and I've seen that happen. And the other is if you have really tight, low latency requirements on the edges of your system where somebody needs to give you data and you need to turn around and say, this is the ID you can refer to that by in the future before you make the round trip to the database. Unless you have either of those situations, stick with integer primary keys, please. So, these kinds of changes are costly and risky. I don't recommend that you all run back to work and say, guys, come on, team, we gotta, no. But if something's really causing you pain, you can make these changes safely by applying these 3 principles and just being creative about the technical solutions that you apply at every stage. Thank you very much. And there's that jobs link again.